Hi, how are you?
Quite okay, thanks.
Perfect. It's great to meet you. So I'm Marie. I know you've interacted a lot with Chelsea, but I'm going to be doing the session with you. Just, would it be possible to have your video on? You don't have to, but it's just, yeah.
I can, I mean, when I'll do the presentation, I'll drop it because it doesn't make sense. But for now, can you see me?
Yeah, I can see you. Yeah,
Perfect.
perfect. Hi. And I love the background as well.
Oh,
The
yeah, one of our meeting rooms.
Yeah, it's very nice. Great. So when you present as well, you can share your screen, right?
Yeah, yeah, yeah.
If you want to do
I'll-
that, okay, perfect.
Wait a minute. Where is it?
To share your screen, you'll need to go on the share button at the
Yeah,
bottom of
yeah, I see it.
the
Yeah,
screen,
perfect.
and then you'll be able to do
Yeah.
it. Perfect. So we'll start on the hour. So we have a little bit of time first. So yeah, so
Okay.
we've got some attendees already, and the way we usually do it. So we'll ask you a few questions and see where the discussion goes, and our participants can also ask questions, which we'll then, you know, we'll see where the conversation takes us, basically.
Okay.
And our participants are all from exciting startups from all over the world, which is really cool. And then the call is being recorded as well, so that we can then upload it on the digital labs with some notes, and others can come and watch it as well.
Okay. Very good.
So yeah, perfect, great, um, and and yeah, we'll go from there. Thanks. Um, I have to say, I got a little bit stuck on the Sentinel Hub website this morning, discovering it and playing around with where you can just like give it a go. I think you even call it play it around or something. It was so much fun, just
Mhm.
using the different filters and looking at different places and how it changes over time. And yeah, I got really excited about it. It's great.
Very good.
Yeah,
Happy
no,
to
it's
hear
great,
that.
and I can't wait to hear more about what you do with it and all the possible applications, because I'm sure the things that I'm thinking of are just like touching like the tip of the iceberg.
Yeah,
Um,
I'll also not. By the way, the attendees that are there, are they listening already or?
yeah, yeah, they can hear us, so we can't hear them, but they can hear us, and they can interact with us on the chat as well.
I mean, we are talking as that we are all alone, but cool. Yeah, I mean, I will also not go into the all the details because then, I mean, we would need a few days.
Yeah,
But yeah, I'll try to briefly, yeah, go a bit more deeper than what probably you realized this morning, and then yeah, then we'll have questions and comments, and then we'll be fine.
perfect. Sounds good. Um, yeah, no, sounds perfect. I mean, I would say let's start then. Um, so I'd like to welcome Greg on the call today from the Sentinel Hub, and he's going to tell us all about their wonderful software and what you can do with the data from them, and some of the uses, the potential uses, and some of the ways it's been used before. So Grega, would you like to introduce yourself a little bit and what you do?
Yeah. So basically, so I'm a CEO of Synergize, a company from Slovenia, a small company, like what 60 people or so. Um, we are in this field for about 3 years when we entered with Sentinel Hub, really. And now, I mean, maybe it's best that I just start with the introduction of the Sentinel Hub.
Yeah,
Maybe that
that'd
would
be
be
great.
the best way. Let me just share the desktop. So you should see my desktop now.
Yeah, yeah, we can
I
see
will
it.
turn off the video because now, I mean, while I'm doing presentation, because it doesn't do any good. Um, and you should see now the presentation in full screen mode, right?
Yes, perfect.
Okay, very good. So yeah, I'll be talking about Sentinel Hub and how it makes the data, the satellite data, easier and yeah, useful for various reasons, including agriculture. Now, and let's start with agriculture and cultivation and so on. I imagine that most of the people on the call are familiar with one of these precision farming applications. So this application specifically is from Class, and then you have one from CropSat, and then you have one from Australian company Satamap. and then you have one from South African company, AeroView. And you have, you have quite a few of these applications. What they all share are basically the satellite imagery that is overlaid over the fields. And this satellite imagery shows the state of the fields so that you can see which parts of the fields are growing better and which not that much. So none of these application is synergized application. So all of these applications are simply using our services, and there are many more of these. I just pointed a few of them, but there are literally hundreds of them around the world, and they all show how the specific field is growing. All of this is based on the satellite imagery, but satellite imagery also shows us many other things, some things that we would rather not see, such as wildfires. In this case, these are wildfires in the Amazon region, so the Brazil forest. But I'm sure that many of you heard about the wildfires going around in Australia. Like these days, they have huge problems. And again, we can easily observe this via satellites. Or we can observe how the water bodies are shrinking all around the world, unfortunately very fast. And again, we can see all of these things that are happening anywhere in the world with quite a decent precision. All of this is possible because of a revolution that happened in Earth observation a couple of years ago. Just to mention that the Earth observation is not really a new thing, and satellite imagery is not new thing. This is around for literally decades, but up until recently, most or almost all of the satellite data were commercial, and you needed to pay to buy it. Then the USGS started with their Landsat program, started this open data policy. But then what happened a few years ago is that Sentinels from the European Union's program called Copernicus came along. And this, I think, really triggered this revolution because these satellites made a lot of data accessible free of charge to anyone. And it's a really good quality data. And it's, here I'm showing Sentinel-1 and Sentinel-2, which I mentioned more briefly later. But they're all, you have Sentinel-3 and Sentinel-5P, and you have all the other satellites. So you have really lots and lots of satellites up there, and many of them are sharing data free of charge. What is it, chat? Someone can't see my screen?
Yeah, hang on.
Okay, so...
Good. So I can see your screen just fine.
Okay, so maybe you handle the lens, and then I'll continue, and you try to solve the issue, or should I wait?
If just one more participant could tell us that they see it, that would be great. Just to be sure, because it would be a shame if none of them can see it, but I'm surprised because I can. Okay, Donata can see it. So then, okay, so the rest of it can see it, which is great. So then I wonder what the lens is doing differently. Yeah, I would say continue, please, and then Lens and I will discuss this and see how we can get him on there.
Okay. Let me go into these two most useful satellites, Sentinel-2 and Sentinel-1. So Sentinel-2 is a multispectral imagery, meaning that it's based on the visual spectral as well as the infrared and shortwave infrared. What is very important is that we get every 5 days we get a new image of the complete world, right? So that's something that really triggered the revolution, because we have so much of data available, and so we have now this data available from end of 2015. So almost, what is it, 4 years now, or more than 4 years now. So the data is in 10-meter resolution, which is, I mean, not what most people are used of the data, I know from Google Maps and alike, which is 0.5 meter of resolution. So 10-meter resolution is less detailed, but these 5 days of revisit time really gives us the world that is very useful.
Yeah, it's impressive.
And we also get lots of different spectral bands, which give us more information than just what we can see with the naked eye. Then the second one is the radar satellite. It's called Sentinel-1. Now this one is basically this one is triggering radar rays to the Earth and then observing their bounces back. And what is interesting with this one is that it can see through clouds. I mean, the multispectral imagery from Sentinel-2, if there are clouds, we really can't see much because we just see clouds. With Sentinel-1, though, we can see beyond the clouds, and we can then detect better how the Earth is changing, also in the areas which are very cloudy. Plus, we get some more information about the water level and also the movements of the land. Now, Sentinel-2 is probably most relevant for agriculture because it's easiest to use and it gives us immediate view on how the fields are developing. Now, another thing that is part of the revolution is the clouds. And in this case, the Amazon Web Services cloud that started this, where they basically copied all the data to the cloud. And you can go to Amazon, and now you can go also to many other places like Google Cloud, or you have the various dioceses in Europe, where you can go and simply access all the data there in a quite an efficient way. And this made it possible for more or less anyone, including companies like ours, which don't have like a multi-million resources, to build global satellite imagery-based applications. And this is where we actually want to help with Sentinel Hub, which simply makes it easier for everyone that is wants to use the data, but is maybe not capable to process the data themselves. Mm. And the easiest way to observe this data is through EO Browser. EO Browser is basically one of our applications, which if you Google EO Browser, you'll go there. And it allows you to go to anywhere in the world and you say, I want to look at the data, you query it, you see the latest data, which is usually just a few days or even a few hours old. And then you say, show me the data. And you see the data immediately. And here on the left side, we see different visualizations, which are based on different spectral combinations. And we can play around with that. We can zoom in. We can create time lapses like effortless. And we can do further queries, like we can do the NDVI, for example. This is NDVI is very important in agriculture. We can do observation on NDVI and we can see how specific parts, in this case the field, are developing, and we can see the harvest cycles, we can see the growth cycles. All of these are clouds, right? The clouds are a bit in a way, but we can filter this out. I think I'll have in the video, yeah, if we filter this up, yeah, out, we can then see the patterns better. So this is how we can then see the patterns without clouds. And you can do all the comparisons and stuff, and it's super easy, it's free. So EO Browser, it's free of charge, you can come. You don't even need to register. If you register, which you just need your email, you'll get a bit additional functions. All of it is free though. Now, EO Browser is perfect if you just want to observe the data. Now, if you want to use this data in your own solutions, which is what we are really keen to see, because then you can build on top of it, we have an API for that, which is a super simple API where you simply say, I'm interested in this specific data set, that specific time period, your area of interest, and some additional parameters, and you get the data immediately. And you get the data either as an image or as a statistical values, which you can then combine into the this kind of patterns, or you get it as a pixel value so that you can calculate further on with it. And it's really, I mean, we are really happy to see how people who, I mean, with different ideas use it for various purposes. Like this guy, he used the data from, I think, 3 months, and he mapped the data so that they visually represent in which part of the growth cycle specific field is, like whether it was just harvested or whether it's growing, and you can see how fields that are nearby are in different growth cycles because of the different crops or because of the different conditions. And it's not just agriculture, people use it for various purposes. They use it to observe they use it to observe the emissions. They use it to, this guy is monitoring which fields are irrigated in the drought affected area in United Kingdom. So they use it to simply monitor illegal irrigation. This guy is observing the polar regions and the icebergs going away. This is the military field in Niger built by US military. And you can see all of these things free of charge with 5 days resolution. And you can really, I mean, you can build things like water observatory, which is another application that we built, where you can simply monitor for all the water fields in the world. You can monitor what's happening, and you can see how water is shrinking. And you can, I mean, I'm showing this application because it's a nice example of how you can do large stuff with very little effort and budget. To operate this application, it costs about 100 euros a month. And you operate something that is on global scale, monitoring, I think at the moment, 15,000 water bodies. Every 5 days, you get a new analysis out of it for practically no budget required. And just to mention that this application is open source, available on our GitHub, so one can take it and modify it for their own purpose to monitor whatever they are interested in and build on top of it. Or you can do machine learning processes. So you can take the satellite data, you can combine this with the labels, and you can predict what crops are growing at some point, in some place, and what in other. If you do that, I would recommend that you check the EOLearn, which is another open source package of ours available on GitHub. Here is the link, so that you can do this easier. And not to be too long, really, to have time for questions and answer. I just want to end with these 5 links, which I think are a very good place to start. I mentioned EOBrowser, I mentioned Sentinel Hub, where you can get access to our services, and EOLearn for the machine learning purposes. So I'll stop here sharing, and now, oh, I see that we have many new people joining in. That's great. And now I'll turn back the video, and I'm available for questions and comments.
Perfect. Thank you so much. I mean, I'm a little bit disturbed by some of the data that we saw, like the lakes that just disappeared and that massive chunk from the iceberg that broke off. But it is really impressive that you can see this every 5 days. That is just, it's insane that just anybody can have access to it, which is brilliant.
And just to comment on that, I think that everyone should have access to it and they should observe it, because I think that the only way how we can appreciate the planet and what's happening with it is by observing it. And what satellite data offer us is kind of the objective view. I think that's very important in the world of today, fake news, where you really don't know what to believe. I mean, satellite data simply show the state, right? You can look at it through different lenses, as we call it, like if you are interested in vegetation or water or whatever. But all of this is really just basically the technical processing of the data, and you can do it by yourself to have a complete control over what's happening, and you can go anywhere in the world and simply look at it. And by looking at it, you get familiar with the patterns, and you see the forest being cut, you see the floods, you see all these horrible things, you see also very nice and beautiful things. But I think that it gives us the information that we need so that we start treating this planet with the respect that it deserves, so that it will be there for like a long while.
What a nice way to finish that. Yes, agreed, massively. So do you have an example where the data was used to then, you know, put in some policies or to make some changes because the data showed that things were degrading or changing? Because I think in many spheres, we see that science or that the expert's opinion is maybe not being used that much to actually make decisions. But I mean, this, you know, it cannot be fake. It is from the satellites. It is the data, like you say, like it is an objective view. It is definitely reproducible because, I mean, it's there. Yeah. Do you have any examples where it was used?
I mean, yes. So this is used, but far from as much as it could be and it should be. A nice example is in European Union, where they monitor the agriculture fields with the satellite data, and it's throughout the European Union. They monitor whether the fields are cultivated in a way that they should be, so that they make sure that the farmers treat the fields again with respect and with the best practices. And I mean, the satellite data again gives the insight which previously was only possible if you went to the field, but you cannot visit each and every field in the country, I don't know, every year, because there's simply too much of it. With satellite data, you can easily do that, and combining with machine learning, where you can identify things that go wrong and then you focus just to this. So yeah, I mean, this is, I think, a very nice example. Then so you have then these water bodies monitoring, where people realize that the water is shrinking, and that's the best seen really from the space. And they started I don't know, introducing policies to use less waters, things like that. Deforestation, again, a nice example. I mean, we've seen I mean, we were, I think, all part of this campaign that happened during the summer when the Amazon rainforest was being cut. And I mean, we were seeing this in two ways. One is the images from the ground with fires and whatever, and then with satellite imagery, which showed the scale of this. And I think that because of all this satellite imagery, it gave the power to the public to push the policies, in this case of Brazil administration. And I mean, again, they didn't do as much as they should, but they did send the army to stop some fires and so on. So it is changing, but slowly. And this is why I mentioned that we should really be looking at this data, because the more that we look into it, the more we can push our governments to actually do something about it.
Yeah, brilliant. I'm glad to hear that, especially with the Amazon fires, for example, that it actually had an impact. So thank you for outlining that. I'm intrigued about what you said about the European fields being monitored and looking at the best practices. So what kind of things can you see, and how, you know, yeah, how do you tell when a field is not being cultivated using the best practices?
I mean, first of all, you can easily see whether the field is cultivated or not, right? And I mean, this is happening often, that the fields are simply left to be overgrown, and which is not a good for agricultural land. You can see when the forests are being cut to become the agricultural fields, which again shouldn't be happening, right? In Europe, we are protecting the forest very much. You can see irrigation practices very clearly. I mentioned, I mean, that example there. So you have people in UK which are actually using GeoBrowser, and again, free tool, to observe which fields are irrigated. And then they go there and they penalize the farmers who do that, because they don't have the right to do it, right? And it's basically impacting the water bodies because of over irrigation. So yeah, I mean, this is used quite a bit.
Oh, okay. And so now we've seen kind of, you can tell if they're doing it right or not, but how do farmers work for it, and how can it help the effectiveness and agility of agriculture and land use?
So this is the other parties. One part is that the governments look into the data, and they basically push farmers to respect the rules. The other one is that each farmer, these are the pictures that I showed at the beginning of the presentation, right? Each farmer can observe what is happening with their fields. And this satellite imagery really gives a nice example over which part of the field should be fertilized more and which less, so that we can use the fertilizer in an optimal way. Or maybe we see that some fields are behaving better than others, so that we put more focus there. And I mean, I'm saying I'm mentioning this because this information provides so much value that the farmers are willing to pay for it, right? All of our users who are developing precision farming applications, they are charged to use this, and farmers are willing to pay, and not much. Usually they pay, I don't know, €1 per hectare per year or something like that. These are the usual costs. But it really, I mean, it gives a lot of information, and because the satellite data are available free of charge, you can really create value on top of it without too much of costs.
Great. And I mean, fearing a little bit in the name dropping here, but are there any apps that maybe are free that, if you're interested, or if you're a startup that is working in that sense, that you can kind of tap into and just have a look at what it looks like and what it does?
I couldn't name things because then I would be putting favorites.
Yeah, fair enough.
But I mean, if they Google, if someone Googles precision farming and then Sentinel data, for example, you'll get probably 200 examples. Really, many of these.
Yeah, I can imagine. Great, thank you. And I mean, we've kind of covered this a little bit, but just to kind of wrap it in that sense again. So our teams, right, on the digital labs, they have access, and like everybody else as well, but they have access to this data. And so if you're a young startup and kind of working in the precision ag, can you just outline again, just really quickly, what the benefits are for the teams to access this data?
I mean, the best benefit of accessing the data is that you get really valuable information, right? I mean, again, if we just focus to agriculture, because that's the theme of this, right? You get every 5 days, you get information of how the field is developing. You can even see diseases to some extent, right? So you can do some monitoring in this respect. And yeah, you are right. So the startups have access to the data. And just to be clear, the data are free of charge, right? So and that's not our thing. I mean, the data are provided by European Union in this case to anyone. What we do provide with Sentinel Hub, we provide an easy way to get access to this data. And your startups have access to our service as well, free of charge. So, I mean, the only thing that they need to do is they need to subscribe to it. Anyone can get a free trial, so they don't even need to contact us for that. Then once they are in and when they tried it, they can, through your initiative, get basically free access to it for at least 1 year, if not more, so that they can develop application on top of it. And what the benefits that people get with this service is that it's super easy to create application on top of it. I mean, it literally takes a few hours, and you can have the global data set, which, by the way, is at the moment about 5 petabytes of data that we are talking about, right? So huge amounts of data. You can have this available in your application for anyone to use in any part of the world, like in a matter of seconds.
Brilliant. That is great. And if I had an idea to work with it, I would jump on this. Well, I'm just going to dive into it a little bit more later as well to try out a little more of the functions. So you mentioned as well, I think you can integrate your own data, right? That is an option on Sentinel Hub. Can you tell us a little bit more about that, please?
Yeah. So, I mean, what people often do is that they use Sentinel data, which are like available globally every 5 days, and then adjust this with the drone data, for example, which are becoming very popular. Drone data are much more accurate because the Sentinel has 10-meter resolution. With drones, you can get a centimeter resolution, right? So it's like significantly better. But acquiring drone data is expensive. So you cannot really afford to do this every 5 days for all the fields in the world, right? So what they do is they take Sentinel data, then they take drone data, we call this ingestion. They ingest drone data into Sentinel Hub, and then they can do machine learning on both of these sources, so that they can use the drone data to actually create a super resolution of Sentinel-2, so that they get the time intervals of Sentinel data, but then at the resolution of the drone data. So by combining these two, we are getting a bit technical here, maybe too much. I don't know about the audience, but the point is that, yeah, you can ingest your data in Sentinel Hub. You can then use a combination of these two, and you can also ingest weather data if you like. You can ingest labels if you're interested in what is very like a buzzy business is to try to predict the yield of, I don't know, corn over one country. For that, you need satellite data, and Sentinel is perfect for that. And that you need labels so that you can train the models on. You can ingest labels in the system in exactly the same way, and then use this using KeoLearn, for example, to extract the machine learning insights.
Brilliant. Okay, that's so interesting. And you touched on something I was going to ask you about next as well. That's climate change, right? So we obviously, like, things are changing the climate, and using Sentinel Hub, you can have data from years back to kind of see how it's changing. How can you use the data to adapt your farming practices, or maybe even what you grow? Yeah, how can you use that data to make the decisions on that?
That's a million-dollar question, which I mean, it's not simple, right? And it's not simple because people are just starting to work on that. So there are no like established practices. And I think that's a huge opportunity for startups to actually start doing that, right? We have the data available. Some data are available even for more than 5 years. In a combination with Landsat, we can go back to 84. So we have what, 40 years of data, right? So you can really observe this, and you can correlate with the climate data, which are as well available, and which you can also ingest in Sentinel Hub. Now, what you do with this, that's beyond our know-how, because we rather try to focus to one thing that we do very good, and that's processing the data. And I think that's really for all the startups in the world to try to tackle this and to come up with the machine learning models to predict what's best to be done.
Yeah, so hear that, guys listening in. This is where you can make the $1 million. And I guess, yeah, prediction of yield kind of comes hand in hand. I guess that's like a smaller model or a smaller system where you don't need to look as far, which is why people are tackling it already. And what stage are we at with that?
I wouldn't say that it's small, really. People are then selling this data to hedge funds. So I guess that the amounts are quite large. And it's not easy to do, by the way, because you need to process significant amount of data. You have a few startups. I think like the Cartas Labs is one that was famous about it. Then there was one in Canada, in North America, which was then sold to another large company. So they already exited. I forgot the name because they don't exist anymore. You have Orbital Watch that is quite famous. So you have large startups, large in terms of valuation, which are really trying to address this specific field, like yield prediction. They are doing it. You have some things that already produces results. I would say that things are still in the early stage. I mean, you can still do it better. You can still do it cheaper. So there is opportunity on that as well. But you could do much more if you would really try to not just focus on what is there, but try to predict what should be there or how you should be doing things, right? These are the things that are still open.
I'm so excited. There are so many solution areas here that you're mentioning. Nice. And that, I mean, yeah, kind of around the yield and the agriculture, I saw that you can also browse soil types and get some information about the soil using the data. So how does that work?
Soil is a bit more tricky for the satellites because, I mean, usually for soil you need to dig in, right? And satellites obviously just see what is on the surface. That being said, what you can do is by using the optical data and in a combination of observing how vegetation is changing, you can basically classify the quality of the data directly from that, right? That's one option. The other option is to use the radar data that I mentioned, Sentinel-1, which also gives you a bit of an insight of the moisture of the soil, a bit about the structure. So you can go there. You can't really classify in details what kind of soil it is. So this you need to get from other sources. But if you use this data in combination with machine learning, then you can extrapolate from one field, or not one, but let's say hundreds or thousands of fields to the complete region, right?
Brilliant. Okay. It's there's so many tools in this one system. It's insane. It's very cool.
Many of these tools that don't yet exist, right? They need
Yeah.
to be developed. I mean, there are tools available to get the data. There are tools available, like basic ones, to do machine learning on top of it. But combining all of this together, that's something that is still at the very early stage. I mean, far from production, and there is a lot to be done and a lot of opportunities.
Yeah, no, for sure. It definitely seems that way. Um, so what do you think are some of the things that are going to, like, what topics or what solutions are there that you're excited about that are going to come out in the next, say, 5 years? And what do you think is going to be developed in the next, I don't know, 10, 20 years when we have, more machine learning kind of knowledge and things like that? Where do you think the data is going to go?
I mean, very important thing to mention, I'm not an agriculture expert, right? So we work really just with the data. So that's my non-expert view from the agriculture point of view. But still, what I'm observing is that most of the agriculture right now is driven only and solely by economy, right? So you grow things that sell better, right? And then what happens then is that people are cutting down forests to plant the palms for the palm oil, right? And that's, I mean, this is really only because it generates some money, and it doesn't include any, let's say, any assessment of what kind of impact this has a few years on. And what I would hope, and this is hope because I mean, I'm pretty much believe that it's possible, but I haven't seen it yet, is that people could use machine learning and data to try to merge these things together, right? So that they create assessment of what should be grown somewhere, like what's the best in terms of the soil type, in terms of the climate, right, to grow somewhere. And taking into account the long-term view as well, not just the right now. And by proposing things that can be grown there efficiently, maybe we can somehow leverage this economy view, so that people obviously want to generate money. That's, I mean, everyone wants to do that, right? But if we can help them do that, yet they do it in a way that it's sustainable in the long term, I think then, I mean, then we have really done a major thing, because then we can avoid the world being destroyed to, I don't know, create the cheap oil for I don't know, sweets and so on.
Yeah, no, agreed. I'm literally, you're giving me so much just knowledge and excitement and things to think about, and I hope our teams feel the same way. And because I know that there is a team that is working on kind of the short term, what can you grow where, using data as well, and the climate data, and coupling that to kind of the data from the Sentinel Hub, which is really exciting. But obviously, yeah, thinking the long term, thinking the monetary side of things and the economy is obviously ties in really well. And so our teams, a lot of them obviously are working on ag tech, that feeds into this, and where the Sentinel Hub data might be really useful for. But we also have a prize with Sinbel Beta and Beta Space, which is all around kind of colonizing space and taking agriculture to space. So what do you think, the data that we have obviously right now looks at the Earth, but how do you think data like the one from the Sentinel Hub can help us take agriculture to space? And what do you think the potential of growing food in space?
I mean, that's a interesting yet difficult question, right? We are focusing to Earth observation, which that means that we observe Earth from space, not the other way around, right? I mean, what I think that we can learn from the patterns that we observed in the Earth, and then we can use these patterns in the space. That being said, what I would hope for is that we still remain focused to Earth, because that's a beautiful place to live, right? And what I would hope is that space is used not for people to run away from the Earth, but rather to, I don't know, cultivate things there that cannot be grown efficiently on the Earth, or maybe that are destroying the Earth, that we basically put all the dirty things out there to the space, so that, I mean, they don't cause much damage, right? This is what I would be hoping for. And I guess that, I mean, it's obviously possible because people are growing things in the International Space Station. Question is whether this can be done at scale and economy and so on and so on. Yeah, I'm looking forward to see that all the things that are not best for Earth being exported to the space.
Oh, I love that view. It's really interesting. And Hiranga in Australia agrees. Again, like participants, guys listening in, if you have any questions, you know, go for it. I'm going to loop a little bit away from agriculture because I was very intrigued by the video that you showed about that, was it a military field that we could see kind of being built? So obviously, I mean, it kind of points to the view that, you know, obviously the satellites are taking pictures of everything, right? And it's not just the field and whether things are growing, and it's not just your field, so everybody else can see my field and my back garden, and also the military things. So how is this, like, or is there some, I don't know, protection on the Sentinel hub? And are there some areas that we cannot see? Or are there ways that you could use this data that maybe would not be so beneficial?
Yeah, people can always do bad things with the good things that are out there, right? I mean, I think that's so. To be very specific, the Sentinel satellites are taking the data from all the land mass, right? And they are taking it in a very systematic manner, and there is no censorship. So everything that is acquired is available, and it's available to anyone. You don't need to ask for permission. You can go there and simply look into it. And your browser is a very nice example where you can do that. And I think this is especially powerful because it really gives to just about anyone the same power that maybe a few years ago only the security institutions in US had, right? With all the money. But now this is available for free with anyone with the internet access. And I think that's important because then we can learn from others, right? We can observe what others are doing. We can observe our neighbors, and we can see that the neighbors are doing something bad, and we can act on it, right? Or we can observe that someone in other countries is doing bad, and we can act on it. Now, obviously, you can do something bad with it. I mean, I don't remember of a case that, Sentinel data would be used for something bad, really, luckily at least. But I'm sure that at some point in time, people, will treat this data in a bad manner as well, right?
Sadly.
There are people out there who do that.
Sadly, yes. There is a question here from Donata. I'd like to know if you think that satellites data could be used to prove compliance and non-compliance.
So the answer is yes for some things, right? I mean, compliance is a wide term, and so you need to put it in an aspect of the legislation of specific country or specific region or whatever. You cannot see when person is fertilizing the land, right? That's something that you cannot see from the satellite data, at least not at the moment. You can see the impact of that. So, I mean, as mentioned previously, in Europe, it's now really happening that majority of the compliance of the agriculture use is monitored with Sentinel data. Now, I mean, there are still parts that cannot be monitored and are checked in other ways. But yes, for sure, I would say that many or majority of the compliance can actually be tracked via satellites.
Brilliant. And would it hold up in court?
I mean,
or has Sentinel data been used in court? Do you know?
Not yet. I mean, you know how the courts are running slowly and the Sentinel data are there for a few years. I'm sure that it will happen, right? I mean, without a question whatsoever. I don't see why it wouldn't hold in court. I mean, obviously, if you can see something on satellite data, right? I mean, if you use the satellite data and then you say someone was fertilizing, even if this is not visible from one way or another, this will not hold. But if you use the data in a proper way, yes, I'm sure that it can. These data are official data, right? They are acquired by the European Space Agency, which is a respectable institution. They are available in a manner that kind of guarantees its that it was not tackled with. The services that we provide also are very thoroughly tested in a way that you can guarantee that the data that came in are coming out as well, right? That there is no manipulation happening in between. So yes, I'm pretty certain that this will be used in court quite a bit, but probably it will take 3 to 5 years more, but not much more.
Oh, exciting. Okay. And do you think, I mean, especially in Europe, we talk a lot about kind of our you know, our personal space and our rights online and our, you know, data rights and all of that. Obviously, like we said, Sentinel Hub takes pictures of everything. Do you think it's going to be freely available for everyone, everywhere in the future as well? Or do you imagine that some people might, you know, have a discussion about it and say, no, this is my backyard and I don't want people to see that? Or
I mean, Sentinel data, they are the resolution of Sentinel data, the 10-meter ones is really safe one, right? You don't see I mean, you can see the backyard, but in a very rough way. So I mean, I haven't seen any concerns in this respect yet. And if you go and look into the data, you will immediately notice why, right? It's not like the Street View or something like that. So no, I don't expect that this will happen with Sentinel data, and I'm pretty certain that they will be there for decades to come. Perfect,
that's good to hear. We have another question. What is the difference between lot sensor data and satellite data? Oh, IoT sensor data and satellite data?
Well, IoT is the data that comes from the sensors which are on the ground usually, right? I don't know, monitoring the moisture or the soil something, where satellite data are coming from the space. So that is the major difference. And you can, I mean, another difference is that usually IoT data is not in such an abundance than the satellite data, right? I mean, you have satellite data every 5 days, whole planet. For the IoT in agriculture, you need to have as many sensors as you need, and the sensors cost something, and so usually there are never enough of them. So what is the best way to do is that you combine these two together, right? You take the IoT data, which measure something maybe to a greater detail than the satellite data, but they measure these at some specific locations, and then you try to find patterns on how this is correlated with the satellite data, and then you can use the satellite data to predict what this IoT sensor would measure somewhere else in the place where there is no sensor available.
Cool, thank you for that. Perfect. And I mean, I'm just thinking of, of research institutes, right, who could use this so nicely. I think, I mean, they must be already, because, so I did a PhD in plant genetics, so that's why I've done my fair share of field trials and been there and had a look at the data, and kind of you go there constantly to kind of have a look at the field. But I guess using this, I could have just sat in my office, checked the data every 5 days just to see that things are going fine, and gone out less frequently, and I could have had perhaps more information even, right? It would have been, how much easier could it make life be? And maybe, obviously, I mean, like PhD, like research is very close to agriculture, but are there other uses and other, like, what are the other areas that you can use the data for? I know we've covered a few, but.
I mean, it goes beyond what you mentioned, right? It's not just that you can sit in the office and look at the data. What you can do is you can write a computer program that does this looking for you and filters out the data and only shows you the data that the computer finds that are potentially problematic, right? And this is, I mean, this is not a theory. This is what is actually happening now in Europe. I mean, at the moment, this is still on the kind of in a pilot stage. Many countries are doing it already, but it's like something that you decide as a country whether you want to do or not. In 2022, this will become obligatory. So all European Union countries will have to have this kind of system in place for monitoring of compliance for agriculture, right? So just focus to agriculture in this case. You can also, what we have a user in Asia where they use Sentinel data to track new buildings. I mean, in Europe, we are used that each building is tied to the building permit, right? Because we are people. But in the developing world, people are building places all around and without the right to do so. And what they do is they see, there is something being built somewhere. Obviously, you don't know from the satellite whether that is a legal or illegal construction, but you see that there is a construction, and then you just go and check that construction. You don't need to go around and check all the places around the world.
Oh, interesting. Okay, thank you. That's a nice little outline. So there's another question here from Waleed. Is there a difference between spots and Sentinel? And do we have access to spots? I don't know what spot is.
Spot is a commercial mission from Airbus. So that is one of the old but still working satellites which take the data and they sell the data. So that's a major difference. Is Spot data are not free, Sentinel data are free. The other difference between Spot and Sentinel is that Spot is 1.5 meter resolution, Sentinel is 10 meter resolution. So Spot is better. On the other side, with Spot, it is very difficult to get data every 5 days, for example. Or, I mean, you cannot get the data every 5 days all around the world. You can get it for some parts of the world, like you say, I'm interested in this specific, 10 square kilometers, and you do that. But you cannot do it on a global basis. In terms of the question whether the data in the Spot are accessible through Sentinel Hub, technically yes. But you need to purchase the data first from Airbus. We do have some research programs in place which make this possible, to be covered by European Space Agency. Not like that anyone could take it, but you can write an application, say I would need to use the Spot data for this and that. And they are usually quite permissive and they accept this kind of applications. But yeah, there's someone, and then the European Space Agency pays for this data, right? That's a very important point. That so you still get the data free, and then you can get the data through Sentinel Hub for that.
Perfect, thank you. Our participants definitely know a little bit more about some of these techniques than I do, so it's great to see that. So we have 10 minutes left, so if there are any more questions, do send them in so that we can make sure we get them answered. Hang on, I had a question and now it's gone. Yes, how, so if I have a really cool solution, I've just been inspired by what you've said, I want to integrate that into my startup, to my idea. Where's best to find sources to kind of teach me to learn it? Is there?
I would suggest to start in two places. One is our website, sentinelhub.com, which has lots of examples there as well. And the other one is our GitHub page, where we host a lot of open source tools, which can be taken and used. They all have an MIT license, so you can really use them. And you can build on top of that.
Perfect. Cool. Thank you. I'll be sure to check them out. And Octavio was asking, how can you observe some Earth space for any time in real time, and maybe via an API? So
real time is depends what you count as a real time. It takes, for Sentinel specifically, this depends on satellite to satellite, but for Sentinel, it takes from 2 hours to on average 6 hours from the time when the data is acquired to when it's available. So that is already part of not real time, but it's near real time. But it's very important. Satellite data take acquisition every 5 days, right? So you cannot really see at each and every moment what's happening. So for that purpose, there are some satellite missions which actually work on the video as well, which would allow that. They are still in the prototype phase, and I imagine they will be very expensive. So I think that observing something on the small scale in real time, really real time, that's something that is not really feasible from the space. It's too expensive.
Perfect, thank you. And we have one more question, which I think is really nice as well, from Mohsen. How can you find new ideas for agriculture with satellites? Is there a place where people maybe post like, you know, I wish for this solution to be developed or something like that? Or is there like a, I don't know, like a chat room almost where people can talk about ideas like this or anything like that, you know?
Yeah, good question. I don't, I mean, I don't think there is some place like that on the internet. I would recommend to visit some of the conferences and events. There is one, for example, organized by European Space Agency in May in Frascati, Italy. It's focused to agriculture, which is why I think will be probably yeah, a very good source of ideas. This is what that would be my recommendation.
Cool, nice, thank you. And one more question from Hiranga. Are there any good ways of using this data to identify biodiversity pockets? Is it just vegetation and moisture maps?
I mean, biodiversity, that it gets tricky if you want to go to too many details, right? I mean, you shouldn't forget that it's 10-meter resolution, so you don't see each and every tree that is there. You see like a forest, you don't see an individual tree. So, but still, if I mean, if what you want to observe is of the scale that fits the 10-meter resolution, then yeah, I mean, you can train the model, machine learning model, to recognize individual features, and then you deduct from that on the biodiversity. I mean, this is being done. The European Union compliance program that I mentioned, they include this as well, but obviously on the scale that fits the 10-meter resolution.
Great, thanks. I think what we're coming back to a lot is this 10-meter resolution that we're all wishing it would be a little bit more detailed, but 10 meters is great already.
But no, I mean, for agriculture use, 10 meter is usually sufficient, really. I mean, we have lots of users who work in agriculture, and yeah, obviously they all wish that it could be better, but then when they start using it, it's usually just enough.
Yeah, perfect, great. So I think with that, if there are any more quick questions, guys, send them in. Yeah, I mean, thank you very much for your time today and for all your insights. Oh, hang on, there is a question from Walid. What do you suggest as tools or strategy for learning and applying machine learning for satellite imagery?
I would recommend that you go to the EOLearn GitHub page that I mentioned previously, where you will see a list of blog posts. We have written a series of 3 blog posts, which basically goes from start to end of the machine learning process for vegetation from satellite imagery, including a Jupyter notebook with all the examples. So you can take that and I don't know, it will take you an hour to read all the text that is there. But then maybe an hour to try out the things that are available from tools, and then you should know all the details that are, I mean, the basic, not the details, sorry, the basics of the machine learning. And then from there, I mean, then you just explore further in various, again, blog posts that we mentioned, links from the GitHub and the tools that are available there.
Yeah, I guess trial and error will take you further. Perfect. So I just posted in the chat again the link to the Digital Labs course, where you can find out a little bit more about Sentinel Hub, as well as where you can subscribe for the 1-year free subscription, and the link to the Sentinel Hub website itself, which is also on the Digital Labs course, of course, but then you can get there directly and you can check it out. And I highly recommend going on the little playground area, where you can dive into the data and see the different filters that show you different things, and you can go anywhere on the planet and look at it over time, and it's really interesting to have a look. And then I look forward to hearing what you've come up with and some brilliant solutions, hopefully. Can you download the EO browser?
Yes, the answer is, I mean, yes, the EO browser is also available as an open source on our GitHub page. So you can download it and then you can use it for your own purposes. And integrate it with the services, right? I mean, it doesn't make sense to download all the data because it's just petabytes of data and you can't store this probably, but you can integrate it with the web services that we provide, and then you can do something like your browser, but for your own purpose by yourself.
Cool, exciting. Perfect. So I think you've given us loads of inspiration and lots of ideas. Do you have any, I don't know, any final kind of words of inspiration for our teams on how to use this data or anything like that?
I would just hope that they use this data for the good of our planet, because I think that this is really needed and it's needed fast.
Yes, I absolutely agree. And that is why TFF is here, to get everybody together to find these solutions and to work on it together. Well, thank you so much, Grega, for your time.
Thank you.
And thank you, the participants as well, for your great questions. And yeah, I look forward to seeing what we all come up with this wonderful data.
Very good. Thank you. And stay tuned.
All right. Bye.
Bye.